Bismillah ar-Rahman ar-Rahim. Today I'm going to talk about the evaluation of the mutual funds. How we evaluate the performance of portfolio managers and the managers of the mutual funds. And these measures also applied in measuring the performance of individual stocks. The big question is whether the rate of return is a good measure of a mutual funds or portfolios. If I give you a very little example here, if we have portfolio A and portfolio B, the rate of return of portfolio A is 6% and the rate of return of portfolio B is 8%. Which is outperformed the other. It appears from this example is the B is outperformed A. Okay? Or A inferior of B, or less performed than B. But we are not considering risk. The majority of people they just calculate the income, and they don't calculate the effort or the risk that they hold to generate the income. This is the problem. One of the people may say it's fine. We have the capital asset pricing model that we discussed in the previous chapter. We said yes, the CABAM consider the importance of risk, but the CABAM, or the capital asset pricing model, this CABAM, measured the expected return, not the actual return. And this CABAM works if the market is efficient. If the market is not efficient, then we cannot use the CABAM, the capital asset pricing model. So now, this leads us to talk about the performance evaluation. How we evaluate our portfolios, our mutual funds, or our individual stocks. Generally speaking, as I mentioned, CABAM is based on the pure theoretical assumptions. Like we have complete information, no transactions cost, or we have a minimum transaction cost. The information is available to all investors. But if these assumptions is violated by the market mechanism, then we are no longer using the CABAM, the capital asset pricing model. Just to remind you, because I feel some students confused from the CABAM. The CABAM is in the security market line. If we want to calculate the required rate of return of A, this security A, then the required rate of return of A is equal this part, RF, risk-free, plus the RM, this part minus this part, RM minus RF times beta. And we consider this is the excess return. This formula is working if the market is efficient. But if the market is not efficient, for instance, if we have undervalued and overvalued stocks, again, we cannot use or evaluate the stocks or the mutual funds. Market benchmark used in the CABAM is often the S&P 500 stock index. So when we are compare our results or our portfolio, we compare with the market return. For instance, if we talk about the Palestine stock exchange, we compare with the Al-Quds index. If we are in Jordan, we compare with the Amman index. If we are in Egypt, then we compare with Cairo and Alexandria index. Generally speaking, some stocks may outperform the market, or the market outperform the stocks. This is the idea. But generally speaking, the market beats or outperform the individual stocks. We could find a market portfolio or a good manager forming efficient portfolio outperform the market, and we say this is efficient portfolio or efficient manager. You see, this is the CAPM, and the assumptions of CAPM saying that the securities must locate it on the security market line. But if this not what is in the market, we cannot use this security market line. So now we are subject to talk about the adjusted risk-adjusted return. For the CAPM, as I said, it works when the market is efficient. But if the market is not efficient, or if the assumptions of the market is not working, we have other measures of performance. These measures, including three main measures, like Jensen alpha. Okay, we have this is the Jensen's alpha. Okay, we have a tremor, and we have sharp. We have tremor and we have sharp. So there are three measures measuring the return of portfolio relative to the risk, and each measure helping in different way. For instance, if you talk about the Jensen alpha, the Jensen alpha is comparing with the realized return with the required rate of return. Okay? For the trailer, a trailer is measuring the excess return with the standard deviation. For the sharp measures the excess return with the systematic risk. Systematic risk is measured by beta. Okay? You need to revise the previous chapter to know about the systematic risk and unsystematic risk. Let's start by the first one, the Jensen alpha. Okay? For the Jensen alpha, we said that the cap I'm saying that the required rate of return is equal RF risk-free plus the RM minus RF, okay, times theta. So we think that this part is equal this part. So if we say the required rate of return minus the excess market return plus risk-free, so it's equal 0. And from the mathematical point of view, so the error here is equal 0 then. Okay? The error in the regression, if we do regression, and we find that RF plus RM minus RF, the error here is equal 0, then yes, the market is efficient, and the required rate of return is equal the right hand side. From the security market line point of view, the required rate of return is located on the line. Okay, but if the error here is not 0, it could be plus or could be minus. In this case, the required rate of return is not equal the actual rate of return. Okay, so the importance of Jensen alpha or Jensen index, as in this textbook, is a measure of the required rate of return, which is a theoretical measure, with the real rate of return, which is actual measure. Because we run this regression, okay, with our expectations. But when we have a real data, we measure the real data, the real rate of return, with the expected rate of return. So again, this in chapter 4, we said we have 3 measures of return. We have the realized rate of return, we have expected rate of return, and required rate of return. So there are 3 measures of rate of return. Generally speaking, the most important measure of return is the realized rate of return. The realized rate of return is the actual measure. So we compare the realized rate of return with the expected or with the required. The required rate of return is measured by this formula. The expected rate of return, the realized rate of return, just remind you, is measured by this formula. If you remind this. Now, we try to compare this formula with this formula. So if this error is significant and positive or minus, then we can claim, or we may claim, that this is have a problem and we should estimate alpha, the error. How we estimate alpha, and this is alpha known as Jensen alpha, then alpha in this case is equal the difference between the actual rate of return or the realized rate of return minus the required rate of return. Just drop this down, RF plus RM minus RF, okay, time beta, and you got here the required rate of return, or the actual rate of return. So the actual rate of return, like this. So again, if the result is 0, so the market is efficient. And if the result is 0, it means the required rate of return, the realized rate of return is equal the required rate of return. If the output is positive, it means our portfolio outperformed the market. Again, if the alpha index here, or alpha, or Jensen alpha, is positive, we said the actual return of our portfolio is greater than the excess return or the market return. Hence, our portfolio outperformed the market. If the Jensen alpha is in minus, we said the underlying portfolio, which is our portfolio, is inferior to the market, or less efficient, or underperform the market. Okay? It's fine? Okay? You have problem? So this is the importance of alpha. Let's take example here. In the morning, I have example from some videos. Let's see this example. Okay. If we have a mutual funds, we can write down the figures. If we have mutual funds earn 9.5%, so the return of the portfolio 9.5% last year. So this is the realized return. The fund had a standard deviation of 10%, so we have standard deviation 10%, and a beta equal to 0.93. So we have beta 0.93, and over the same period of time, the S&P 500, which is the market return, generated on 11%. the RM is 0.11%. Return with the standard deviation of 14%. So the standard deviation of sigma M is 0.14. The return on the treasury bills was 4%. Return of the RF then is 4%. Okay. Now calculate the Jensen alpha. Okay. Calculate the Jensen alpha here. Okay. Do the calculation, please, and tell me the result. Again, the return of the portfolio is 9.5. The sigma of the portfolio, or the standard deviation of the portfolio, is 10%. The beta of the portfolio is 0.93. The market return is 0.11. The standard deviation of the market is 0.44. The risk-free is 0.04. So what is the result? Yes, so it is minus 0.01. So what's your conclusion? Just underperform the market. Just do. Let's do it. So the Jensen alpha is equal the required rate of return, which is 9.5%. Okay, minus the risk-free. The risk-free is 4%, plus RM is 11%, minus we have the risk-free is 4 times beta. Beta is 93. Okay, 0.93, and now the results. So the results is equal minus 0.01. So the conclusion is this portfolio or this mutual fund underperformed the market. Okay. If this positive, then outperform the market. If it is zero, the market is efficient, and the required rate of return is equal to the realized rate of return. The difference, this is the error. This is the error again, because what is the error is the expectations of what exactly mean. It means the investors overvalued the investment. When we have negative, it means the investor overvalued their they overestimate the required rate of return. Yes, if it is negative, because this side is the required rate of return. So we can conclude that the investors overestimate the required rate of return. If it is positive, so the investor is underestimate the required rate of return. If it is equal zero, then the investor has accurate estimates for the required rate of return. Okay? Let's do the Jensen alpha in different ways. From the chart, look at this chart. Now, okay. We have like this chart. This representing the actual or realized rate of return. This is realized rate of return, which is actual. This is from the historical price. We called some students and asked them for the next month to try to expect the return. Okay? What is the return of the next month? Okay, so the students, they try, this is the actual again, they try to expect the return for the new months. So tomorrow, what is the return, and the day after tomorrow, and till the end of the month. And they do like this. Okay, students do like this. We close the portfolio and wait after 1 month. And we look back and we took the historical prices for the previous months. And what we have like this. So this is the actual and this is the estimated. So this is the difference, is the error. The error in the estimation. We call the student back. Okay? We give them some training courses in how to estimate the stocks or the portfolios. Then we do this again for the next months. And again, this is for the next months. And what we observe, little change in the work. Then we called expert people and we told them, okay, do this. Expect for the next months. And this is a real experiment done by I think Ohio University and Yale University. They brought some students and they do some courses for them. At the end, after 3-4 courses by expert people, the chart looking like this. Okay. Is
less error.
Less error. Okay, we cannot claim it's typical to the expected rate of return. So this is here is the actual, and this is the expected. We have less error. If we select randomly from the streets people and bring them to this meeting and say to them, okay, try to expect for the next month. And at the end of the next month, we call back the data and draw the chart. What we observe again, we observe things going like this. Things not related. Yes. So this blue line, this big error. So here is the Jensen alpha. So this line is the required rate of realized rate of return, and this is the required rate of return. Then the market, if the market is not efficient, again it means we have more uninformed investors. And if the market is efficient, we have more informed investors. It's like we had some students, MBA students, and brought them to the meeting, give them some training courses in how to estimate and how to calculate the return, how to see the data, how to read the data. Then we do this for many times till having the less Jensen alpha. What we conclude in this case, we conclude that the more informed investors in the financial markets, it means the market more efficient. And the less informed investors in the financial market, the market is not efficient. And these things is not in your textbook, is important because recent changes in 2009, 2012 make changes in the understanding of the financial market. And as I told you, last year or the year before the last year, 3 people, they won the Nobel Prize because of these things. Okay? So this is the idea of how to prove that the market is efficient or the market is not efficient by using the Jensen alpha. In terms of evaluate the mutual funds, again, we expect our mutual fund of having the positive Jensen alpha. This is in terms of the markets. If we have 2 mutual funds, then the greater alpha is more preferable. Okay? If we are comparing between 2 different mutual funds. We have the mutual fund A and the mutual fund B. The one with more alpha is more preferable. And the beauty of using the Jensen alpha is a standardized methods, because we compare the return for each mutual fund with the markets. So we compare A with the markets, B with the markets, so we have a standard measure of risk-adjusted return. Okay, any question? Any question?
No.
Sure, no? If you read, you will ask. Okay. Now let's talk about the second measure of risk, which is tenor. Okay, tenor. You've experienced about tenor? No?
No.
Are you sure? This is the first time. Okay? Is this the first time to know about tenor?
Yeah.
Okay. So the tenor is important to measure the excess return with the systemic risk. With the systemic risk, okay? The tenor. The formula of the tenor is going like this. In numerator we have the excess return, which is the RM minus, the return of portfolio minus the RF. Okay? Divided by the systematic risk. So the systematic risk is the beta of the portfolio. We should observe, if we are lucky, that the return of portfolio exceeds the free rates or the risk-free rates. The higher the tenor ratio, it means the more efficient the managers. So if we have two mutual funds, we calculate the tenor for the first one and the tenor for the second one. The one with the higher T, it means more efficient managers. Let's take example for this tenor. Okay, take this example. Any question before the example about the tenor?
No.
Again, the tenor is a relative measure of a relative adjusted return relative to the systematic risk. And this is a risk-adjusted return measure. And each measure, each tools measure different things. As I explained in the Jensen alpha, measure the difference between the actual return and realized. This relative to the systematic risk. Okay, so we have two example in this case, the return of portfolio is 5.9 for portfolio A. For portfolio B is 7.2. The RF risk-free is 0.07%. Okay, be careful in the percentage. And the RF is 0.09%. The standard deviation of B is 8.6%. And here is 26.2%. Now, with these tools or with this data, can you calculate the tenor? Yes, we need beta. So beta is not available in this example. Okay? So you may calculate beta. How you calculate beta? Okay, sigma I divided by sigma B times rho I m. Just to remind you, beta is sigma I divided by sigma m times rho im. Okay, later on I will ask you like basic question. Be careful. Okay? I will give you another bit. So we have 5.9%, 9.3%, RF is 0.07%, and we have 0.09%, and beta B is 0.7 and is here is 1. Now, look at the data. Look at the data. What you observe, we observe that B, the return of B is greater than the return of A. So, some people may conclude that B outperform A. Let's see by using trainer whether this is right or wrong. Let's calculate the trainer of A and the trainer of B. Okay, so trainer of A, so the trainer of A and the trainer of B. Now do the calculation. 0.08. 0.08.
7.
Sorry, 0.08. Okay, in the second. Double check your answer, please.
0.74.
0.1. Are you sure? Do the calculations again.
23.
No. Look at this 5.9%. This is 9.3%. This is 0.07%. Yes. And here is 0, okay? And the beta B is 0.7, the beta B is 1.
0.1.
And here 0.1, okay, and 0.08. So in this case, the B outperformed the markets. Okay. Please double check the answer, please. Okay. Uh, 5.9% minus the first one minus 0.07%. Okay, divided by the beta 0.7. Okay, let's now to take the example related to the sharp. Okay.
0.1. لا
0.09. Yes. 0.09. Okay. Okay. Now for the third measure of risk-adjusted return, we will talk about the sharp. Yes, the second one, or B, outperformed A. Okay, let's talk about sharp now. Sharp. For sharp, just replace the beta with sigma. So we have sigma. Look at this. Sharp. So sharp is equal the excess return divided by the standard deviation of portfolio. The importance of sharp is a measure of excess return relative to the individual risk or standalone risk. you should think on each measure of risk-adjusted return and why we are using each measure. Again, this chart is using the excess return relative to the unsystematic risk. The trend for systematic risk. The Jensen alpha for
actual and realized.
yes, actual and realized. Actual and required rate of return. Required rate of return. Okay, let's take example for the Sharpe ratio. We have two stocks, A and B, and we have this data for A and B. 5.9%, 5.9%, and we have 7.2%. The RF is 0.07%, and here we have all 9%. It's similar to the previous one, but the change in standard deviation of B is 8.6%, and here is 26.2%. Yes, 0.66 or 0.67. So this is again the Sharpe. The Sharpe in this case for A is 5.9% minus the RF 0.07% divided by the standard deviation of B. So the standard deviation of B is 8.6%. For the Sharpe of B, you do like this: 7.2% minus 0.09% divided by 26.2 equal 0.27. So let's here Sharpe for the first one is 0.66, 67, and for the second one 0.27. Okay, look at the two results. So which you prefer, A or B? A. However, A has less required rate of return. B has a higher rate of return. But when we adjust for risk, for individual risk, we have A is a higher rate of return relative to the risk. So our result now change because we include the unsystematic risk. In terms of unsystematic risk, we can conclude A is more preferable than B. It means the relative return of A adjusted with risk is higher in A than in B. In other words, B holding higher risk to generate 1 unit in return than in A. It depends because each index measures different things. Sharpe measure the unsystematic risk. The Trainer, the systematic risk. The Jensen alpha is like the tools. It's like the tools box. Tools box, what you want to measure? You want to measure the relative systematic risk, or relative unsystematic risk, or the required rate of return. It depends on what you're asking about. But the important thing is to use the three measures of risk, just to be sure that the performance of your performance.
Picture.
Huh?
To give the full picture.
Yes. Let's see another example about Jensen alpha or the other. Okay, if portfolio manager X achieve a return of 15%, okay, if a portfolio manager X achieved a return of 15%, so we have return of X 15%. Okay? Pay attention, please. So the return of B is 15%. The return of X. And with a beta of 1.1, so beta here is 1.1. When the market return was 14.6, the RM is 14.6. And the risk-free rate was RF is 7%. Now, calculate the Jensen alpha, please. Calculate Jensen alpha or Jensen index. Okay. Sorry? No?
أكم بيتا؟
How come zero? Definitely not zero.
بوينت 9 لا سالب ماينس رقم صغير. بوينت 9 ولك هذا بعد زائد واحد.
الناس طلعت محازين بسألهم
ما كان ماينس.
مين قال لي؟
أنا
إنها الأرقام أصلا
طلع رقم صغير كبير.
والتيار حسب
لا
سالب قديش؟ The result is minus, then the Jensen alpha is equal minus 0.0036.
Yeah.
I observe some students, they don't have the scientific calculator. Around 70% of the students in the class, they don't have this. So please don't train yourself on the exam.
Okay.
This is a bad indicator for my student. Okay? So it's up to you then. It's your problem. Because I see students, they have different answers. Try to recalculate this and ensure that you have this. Okay, let's do it for the Jensen alpha. So Jensen alpha for X is equal the 15%. The required rate of return 15% minus
7%.
Ensure you are doing a proper calculation, please. Okay?
7%.
So RF
7%.
is 7% plus the RM is 14.6%
minus 7.
minus 7
Multiplied by 1.
beta is 1.1. Okay? Have answer for this and have answer for this. Then the difference will be minus 0.0036. Do the calculation again, please. If you have different answer, then check your calculator. Check your skills in using the calculator, please. Okay? See, this is X.
Yeah.
Let's see Y. For Y, okay, we have this data for Y. For Y, a portfolio manager Y achieved 13.5%. So 13.5% return with a beta of 0.8. This is not 0.8%. This is 0.8. This is percent. This is percent. And then calculate the alpha. The market return is same, and the RF is the same. Calculate the alpha, please. Yes. Calculate the alpha for Y. Point 004. Would you mind to do the calculation, please? Yes.
Yes.
So this is alpha Y. Alpha Y.
اوكي. لا ما فيش واحد.
عشان اسمعوا. مش مشكلة، أنا بنحكي عنه. Okay. Yes. So the alpha Y is equal the actual rate of return of Y, which is 13.5 times or minus the risk-free rate 7%. Be careful. Look at the. Okay. Yes. But why? But here there is no. Yes. Little mistakes may have problem in your answer. Okay. Okay, no problem. What is the output? 004. 2. Yes. Okay. شكرا. So the answer then, if you look at the X and Y. Look at X and Y. What we observe in X? We observe that X having higher rate of return. But when we calculate alpha, Jensen alpha, what we observe that Y outperform X. It means when we adjust for return, for risk, Y outperform X. In this case, the required rate of the realized rate of return for Y is greater than the required rate of return. Okay? Huh? Okay, what time now? Okay, we almost finished. No, 5 minutes. Okay, let's take another example for the sharp and channel. If the portfolio manager of X return is 15% again, and risk-free rate was 7%, yes, and beta was 1.1, beta 1.1. So now in this data, calculate the Sharpe, or calculate the trend, please. Calculate the trend. Point 0727, and the Y is 0.0812. Yes, by using same data. So what we observe is still Y outperform X
Yeah.
in terms of the trend.
Yeah.
If I add more, if I give you sigma of X, or the standard deviation of X was 13% or 30%. Yes, 30%.
0.26.
30%, yeah.
0.26.
And for Y is 0.25%. Calculate Sharpe ratio. Okay. Sorry? 26.26, and the second. So try to have 4 digits. Okay. 0.26. For the Sharpe ratio, which one? The X. Okay. And we conclude that we have 3 measures of adjusted risk return, and each measure having relative issues. The Jensen alpha measure the difference between the realized rate of return and the required rate of return. The Sharpe ratio measure the excess return relative to the unsystemic risk measured by standard deviation, and the Turner measure the excess return relative to the systemic risk measured by beta. Think if we have negative Sharpe ratio, the higher Sharpe ratio in negative is preferable. Now we finished chapter 5, and next week we will talk about chapter 6. Okay? So try to revise all chapters, because chapter 6 builds on the Weber factors.